Hi guys, welcome back. So what is recursion? Recursion is nothing but function calling itself is called recursion. So let me explain recursion with the help of example. So this is a program. Print numbers from 5 to 1. The obvious solution that everyone writes is with the help of for loop. For int I is equal to 5, I greater than 0, I minus minus and print of percentage d comma I. So with this for loop you can print the numbers from 5 to 1. So this is very obvious solution each and every C programmer writes. So let's write this program using recursion. So in the main function I will write print numbers function and I will pass parameter as 5. Okay, and in this void function print numbers int n, and this will print the number percentage d comma n, and it will call the same function. I'll call the same function but with different value n minus 1. N minus 1. Now we have to add a base condition. If n is equal to 0, we have to return. Okay, so the program is just to print numbers from 5 to 1. So whenever you encounter 0, you don't call the recursive function again, you just return from there. So whenever you call this function, the recursion state will be like this. Okay, so print number 5, it will print the number 5 and it will call the same function but with a number less than this, 1 less than this, so it will be 4. Okay, as I explained you in the function calling concept, so whenever you call the function, the current function variables state and the next line address will be pushed onto system stack. Okay, so now you will call this print number with 4. Now the 4 is called, 4 is printed and print number 3 is called. Now again 3 is printed and print number 2 is called. Now 2 is printed, print number 1 is called. 1 is printed, print number 0 is called. Now after 0 we have encountered n is equal to 0. Whenever we encountered n is equal to 0, we are not further recurring. We are not calling the print number function with n is equal to 0. We are just returning. So what happens? It will return from here to print number 1 state. Okay, and after completing executing print number 1 state, it will return back to print number 2. And from print number 2, it will return to print number 3. Now print number 3 to print number 4, print number 4 to print number 5, and from print number 5 it will return to main function. Let's see how this works. Okay, function now. Okay, now n is equal to 5. We can add a watch over the variable n. Okay, you can see the value of n over here. Now f10, n is printed. Now again same function is called. Now n value is 4. Now 4 is printed, again same function is called. N value is 3. 3 is printed, n value is 2. 2 is printed, n value is 1. 1 is printed, n value is 0. Now when n is equal to 0, we are returning. We are going back. And print, we are going back. Going back. Going back. Fifth state. Going back. Came to main function. Now if you see the output, this is the output. 5, 4, 3, 2, 1 is been printed. And you complete execution of this program. So in this recursion, you will see this is the recursion tree and this is fifth state, fourth state, third state, second state, first state, zeroth state, and from zeroth state you are moving back to previous states. Okay, what happens if I don't keep n is equal to 0? Okay, let's see. If I comment this, what happens? I comment this and I am running this program now. Okay, so what happens? The recursive function will go into infinite loop. Okay, let's remove this debug, continue. You see, so the recursive function has gone into infinite loop and it will crash. See the output. A stack overflow has happened. An unhandled exception and stack overflow has happened. The program has crashed. Why? Because as I explained you in the function calling concept, so whenever you call any function, that particular variable state and the next function next line address will be pushed onto stack. Now if you don't write print if n is equal to 0, if you don't return, okay, the things get pushed whenever you are calling the same function. The value, okay, in this state 5 is pushed and the next line after this is this one. That's it, end of flower braces. Okay, nothing is there. Okay, 5 comma next line address is pushed, again 4 comma next line address is pushed onto stack, 3 comma next line address is pushed. Like that it keeps on pushing the things. Okay, and for every program a limited stack will be allocated. Okay, for example 256 MB, let's think like that. So after 256 MB, system cannot allocate an extra memory to push the things, push the variable value and to the next line address. So it will say stack overflow has happened. So I can't run this program anymore. So you will get an output saying stack overflow unhandled exception. So for any recursion program, writing the base condition is very important. So you have to write a base condition for any recursion function. So these are the key takeaways from the recursive topic. So for every recursive function, the base condition is very important. If you miss this, then the function is not going to work as we expect. So base condition is very important. So every recursive call will push the state to system stack. State in the sense the variable values, it will push into the system stack. Okay, and the stack overflow occurs if the base condition is not written. So for every recursive function we have to write the base conditions. Okay, so these are the key takeaways. So in the next videos we will see few examples on the recursive functions. Okay, see you in the next video. Catch you in the next video. Bye bye.